Okay, so where we left off, we were finding the VI with which the football was kicked. So we had 5 meters, which went in as a positive meters per second because it was going up for the VF, minus 2 times negative 9.81 meters per second squared because it was going down, and the delta D below the window is 12 meters, and it's positive because it's going up. So VI squared will equal 25 meters squared per second squared, and the negative and negative become positive. 24 times 9.81, 235.44 meters squared per second squared. Add them together, so 260.44. Take the square root, 16.14 meters per second. So that's the overall VI. And we're going to use that then to find A and B. So A wants to know, how high does the football go above the ground? So if we know that this is 16.14 meters per second, you could use this as your VI, and you could use this as your VF, and you could find the delta D in one shot. Or you could find the delta D of just this top part and then add it to the 12 meters. It makes absolutely no difference which way you do it. To do it in one shot, so part A, looking at all of it, so we would have VI, VF, and A, and we want delta D. So we would use VF squared is equal to VI squared plus 2A delta D. So VF squared minus VI squared divided by 2A will equal delta D. So if you're doing it the whole thing, the VF, actually either way, the VF goes to 0. Negative, if you're doing the whole thing, then it's 16.14 in here. If you're just doing the top piece, you'd put the 5 in there. And then you'd have to 5 meters per second, and then you'd have to add the 12 meters onto it. So negative 9.81 meters per second squared. Don't forget to square your 16. And when you do, you get 13.274 meters for your answer. Okay? That's part A. Part B wants to know, how long is it in the air? So we know A is equal to, sorry, my sheet's moving, there we go. A is equal to VF minus VI over delta T. If we look at just going up, then VF is 0, VF minus VI over A, but VF is 0. The VI is the 16.14 that you found, and the minus sign is from the equation. And this is A, and it's negative 9.81 meters per second squared. So your time to go up is 1.645, I think, seconds. But the question says, how long is it in the air? So then you would go, therefore, delta T total is equal to 2 of that. So delta T total should be equal to 3.29 seconds, give or take a few digits, depending on rounding. Okay? So that's number 4. Number 5 on this sheet. A teacher performing an outdoor demonstration suddenly falls from rest off a high cliff and simultaneously shouts help. When she has fallen 3 seconds, she hears the echo of her shout from the valley 4 below. Speed of sound is 340 meters per second again. How tall is the cliff and how fast is she going? All right, so there are 2 parts. There's the teacher who falls, so VI is 0. A is 9.81 meters per second squared. And then there's the sound that comes back, and it's traveling 340 meters per second, and it's an average speed. And it says she falls for 3 seconds before she hears the sound. So the delta T for the teacher and the delta T for the sound is 3 seconds, right? Because here's the teacher falling, and she screams, help! And it goes down, hits the bottom, and it comes back up. And they meet at this part. So we can find how far the teacher fell in the 3 seconds, and we can find how far the sound traveled in the 3 seconds. So to find the delta D of the teacher, it's going to be VI delta T plus 1/2 A delta T squared. This goes to 0. So delta T of the teacher, 1/2, 9.81 meters per second squared times 3 seconds squared. So 4.5 times 9.81, so 44.145. And this T is teacher, not total. Then for the sound, we know VAV is equal to delta D over delta T. So delta D of the sound is just going to be VAV times delta T. So delta D of the sound is going to be that 340 meters per second times 3 seconds. And you get a delta D of the sound to be 1,020 meters. So now the question is, what do you do with these two? And the picture is what's going to help you. Because look, we know this is 44.145 meters. And we know this whole thing down and up is 1,020 meters. What happens if you add them together? Well, you get a delta D of 1064.145 meters. But what is that delta D? Isn't it really twice the height of the cliff? And so to get the height of the cliff, you would divide it by 2. And so it should be 532.0725, assuming I can do math in my head. Okay, because you've fallen some distance, and the sound has gone all the way down and come back to meet you. So if you add up those two distances, you'll get twice the height of the cliff, and so then divide by 2 to get the height of the cliff, which is what the question asked. That's part A. Part B said, how fast will she be moving when she hits the ground? So you're looking for VF, and we know VF squared is equal to VI squared plus 2A delta D. VI is 0, so VF squared is equal to 2 times 9.81 meters per second squared times 532.0725. I'd like to point out that this cliff is over a half a kilometer high. And when you do this, she's going at a speed of 102.17 meters per second, which is totally insane. Way too fast, which is to even think about surviving. But if this was me, hitting the ground wouldn't kill me. I would have already died of a heart attack when I was at the edge of the cliff. But it leads to question C, which says, who designed this demonstration anyway, and why did she agree to it? Exactly. Seems a little crazy. All right, so that's number 5. Now, I don't know if you noticed the title on this sheet, but it was, okay, so maybe a few more kinematics questions just for fun, because the title on the one before was the last of the kinematics problems, and then all of a sudden it wasn't the last. There's a few more on the sheet on the bottom, but they're a little tougher, but it'd be a shame to copy a sheet with a blank side. So on the back of that sheet, if I was giving out handouts, would be this one, which is entitled, Seems Wrong to Waste the Backside of a Sheet. Now, these ones are really more of a review of the tougher ones. Every one of them you've done one like already, and we've gone over. So I would like you, just trying to get it clear, I would like you to try the first 5, okay? And hopefully at this point you are getting good. You're not looking back and seeing what you've done, that you're able to set them up without copying off another question, because if we were to have a test, you wouldn't be able to do that. Look back, I mean, in your notes. Okay, so try these first 5, all right? And the next time I do a video, I'll go over them. Thank you.